and where it's incomplete, right? Where we can still see both the product, the garnet, and the reactant of that plagioclase. And if it happens slowly, the garnet would be completely gone and we'd only have plagioclase. So that also tells us how fast these rocks are moving up, and that it had to be pretty quickly.
How fast is fast?
Here.
Well, they're up past biotype by 80.
Yeah.
Okay, so the way you answer that question is you use a different system. So we use argon as a cooling agent. Argon doesn't tell you when the mineral formed, it tells you when the mineral cooled. Because at that point the lattice shrinks so that it can hold on to the argon. All right, so we have minerals that tell us when they grew, but we have minerals that tell us when they cooled. And the biotite here cooled by 85. So the garnets form at 99 and it's below 300 degrees by 85.
But chances are they stayed at high temperature for a longer amount of time after the garnet growth. And so in most places where we've seen this, it's like less than 5 million years for them to pop up.
That's fast.
Yeah.
Are there some plagioclases that were not garnets before?
Yes, you'll see only the plage that's right around the garnets is probably part of that reaction, but definitely there's other quartz and plagioclase throughout the rock that's just part of that original rock composition.
All right, so just for logistics, because we're having an early dinner, we have to have an early lunch.
Yes.
Geologists are very food motivated, so all of our things are named after foods, like boudins. So anyway, what we're gonna do is just spend a half hour walking up this ridge, that one right back there, looking at swirly rocks. Oh boy. And then we meet back here at like 11:30, 11:35 and just have lunch on this ridge.
Can I ask one quick question?
Of course.
What difference in commonality
Could you
would this migmatite have compared to like the Chilean migmatite, which is the only other migmatite I'm aware of?
actually, Stacia could answer that question
Okay.
about. So there'd be a timing, and there'd be how it deformed. Stacia, what's the age of the Chilean migmatite?
Chilean is older, like 110-ish, but it kind of has, I think, like a 10 to 20 million year history.
Okay. Well, basically what I was doing, since I love migmatites as they're beautiful rocks to look at, I was just wondering what the similarities and differences were between this and the Chilean, since it's the only other migmatite I know about.
Yeah, it's, well, I haven't seen this one yet.
Okay.
But the Chilean is pretty complicated.
Okay.
Have you been to the slaughtered hog outcrop?
I don't know. I was on the big long outcrop where there's that little place
Close
you
to
can park.
Pateras?
The same one where
Yeah.
Nick, but right at Chilean.
Okay.
I was there,
Okay.
you know, right where Nick did a little video in the Chilean migmatite.
Okay. Yeah, those rocks I think are pretty complicated, and there seems to be multiple generations of melt. I think a lot of it there is injected.
Okay, and
And then
they think this is
becomes
just one.
deformed.
This is just one period of melt here.
Well, it sounds like there's two periods.
two periods?
One with the one at the 110, and then another at the 98 or so.
All right.
But I think all of this is more in situ, where it's the rocks that were here actually melted, instead of other migmatites will be where you have had
Something
melt
injected
that's
into 'em.
deeper, injected, and then they get deformed and
Right.
can have kind of the same appearance to
Right.
them. And it's all about that deformation history.
All right.
Yeah.
Thank you.
Mhm.